Just before we start, how many of you are you dealing with antibot issue? Okay, so we can go. So, very happy to be here. I'm Fabien Vauchelles, and I've been deeply passionate about web scraping for years. And my enthusiasm led me to explore the fascinating world of proxy and antibot system. I work at Wireman. It's an amazing company specializing in revenue management within the transportation industry. And our work at Wireman involves handling millions of prices on a daily basis, which require substantial investment in web scraping technology. I'm also the creator of Scraproxy, an open source proxy aggregator. Scraproxy allows you to manage and to route traffic through cloud providers and proxy services like Zeit. I encourage you to take a look at this distorting proxy. It might pique your interest. And before we start, I would like to underline that this talk is my point of view in this cat and mouse game because I always play in the mouse team. So, before we start, I would like to share with you a little story. A decade ago, I found myself in a conversation with a friend who worked in the HR industry. It was a time where AI and NLP were just at the beginnings. And during a conversation, we stumbled upon an idea. It is always challenging to identify potential candidates in the IT industry. So we wondered, what if we could predict if someone might leave their job within the next 2 months? It could be a very nice idea, so we can reach out to them and offer them exciting opportunities. So we thought, to do that, we need data. And of course, as you probably know, machine learning algorithms need a large amount of data to train. So we need a lot of data. We need profiles, millions of profiles. So we thought, okay, let's go and gather them. So the real challenge came at this point of time. When I tried to collect hundreds or even thousands of profiles, I hit a wall. I was new on web scraping. So I checked on Stack Overflow for solutions. And the advice was to use proxy. That's what you hear. But proxy were expensive. So my idea was to buy a virtual machine on Amazon and install Squid Proxy to get fresh IP. So it worked a little bit, but I faced the same problems, always blocked. So how to get many fresh IP addresses? That's all that we want. So the idea came into the form of a basic script. So by destroying, creating, and automatically installing new VMs, the IP address will change. And it was the birth of the Scraproxy project. But my journey had just begun. Using VMs from cloud provider doesn't prevent you from being blocked. So that was something I didn't understand at this point. Something known as the Turing test. So let me show you another example. When you come here, you purchase a flight ticket for Dublin. So it takes these forms. So I'm a human living in Paris, and I'm so excited to be here. So I'm buying a round-trip ticket during the evening, using Safari on Mac, and I use a DSL connections. This interaction reflects a natural and organic behaviors. But when it comes to web scraping, it often takes different forms. It's more, hey, I'm scrappy, living in data centers, and I'm clearly not interested in the web scraping submit. My goal is to retrieve thousands of prices for many airlines, and I'm accessing with a deep link at 2 a.m., of course, using Python within my Dockers. My provider is AWS, and I love to randomize my user agents. Honestly, it doesn't seem like an organic behavior. And the website understands that, and the antibot too. You see, they conduct Turing tests on your behalf. So the question is, how do antibot systems assess us? It's very simple. They meticulously scrutinize our browser stack. Starting from IP address, they know where we are coming from. The protocol header reveals details about our operating system, our browser's versions. They execute JavaScript to know our system and browser configurations. They also track our navigation patterns. They know the sequence of web pages, the sequence of events such as mouse movements, and they cross-check every signals to validate the consistency. So now, let's dive into each layer of this stack. So the first layer is the IP address layers. And this is the very first piece of information a website obtains when we connect to it. And it is a gold mine of information. Are we accessing from a data center? Are we accessing from an IP address? Are we accessing from a mobile device? Is our connection originating from the opposite side of the world? If we are purchasing a ticket from Paris to New York, is our connection originating from Dublin? It's not consistent. If we have US IP address, does the browser time zone is set on Western Europe? It's completely inconsistent. Moving to the second layers, let's understand the power of protocol headers. We can distinguish three protocols. So the first one is the TCP/IP protocol, the second is TLS, and the third one is HTTP2. So first up is the TCP protocols. The request for comments describe how TCP protocol should be implemented by operating systems. But in practice, implementation often vary not only from one operating system to another, but even between the different versions of the same OS. And by examining statistically each header, it's possible to deduce which operating system is responsible for sending the packets. Second up is the TLS protocol. TLS stands for the Transport Layer Security Protocol. It's an encryption protocol on top of the TCP protocol, and it's used everywhere. So now let's understand how it's working. When the browser wants to establish a secure connections, it will initiate a negotiation with the servers. And this negotiation is called the handshake protocols. And during this process, the browser will send a client hello message. And this message includes a lot of supported algorithms by the browsers, a lot of encryption protocol, plus options. And this list is called the cipher suite. And of course, the server will select the most compatible and secure protocol, and they will initiate a key exchange. And that's where the magic unfolds. Each browser has its unique list of cipher suites. This led to a TLS fingerprint. It is called the JS3 fingerprint. And this fingerprint can say, hey, it's Chrome, it's Firefox, it's Edge, or it's Python. So the third up is the HTTP protocol. HTTP2, sorry. The HTTP2 headers also, it's kind of TCP protocols. They introduce variations on settings, priority flags, and also the list of fields, the order of the list. And by examining this information, it's possible to statistically deduce which browser is responsible for sending the packets. So now I think you know where I'm heading with this. If you are Firefox on Windows, but your browser stack suggests that you are Chrome on Linux, it's a red flag. And it's not finished. We can also discuss about HTTP protocols. We can fingerprint the HTTP2 headers. So this is a little bit of code of a well-known anti-bot system for Node.js servers. The code is public on the internet. It's just 3 lines of code, but it's bulletproof. This function lists the order of request headers. And because when we code a scrapper, we try to reduce the number of headers to the bare minimum. We strip away as many headers as possible to get a simple and maintainable payload. But when we read the functions, we understand that all headers are vitals. Even they are not used by the API, they are crucial for the fingerprint process. And it can block most of the web scrapers. And as you know, all browsers can execute JavaScript. And it's truly astonishing how much information they can get from JavaScript. They can get detail about time zones. They can get detail about fingerprint models, GPU models, GPU fingerprints. They can get detail about the number of speakers, the speaker models. They can get the webcam status, the microphones. They can get the battery status, the list of font installed, the list of extension installed. They can know also if you have an ad block. They can know if you disclose your real IP address with an RTC leak. They can know also the size of your screen, and they can get many informations. And if you are using mobile applications, it's quite the same. They can know if you have activated Android debug. They can know your architecture. Are you using ARM architecture? Because most emulators use Intel architectures. And they can know the Android version, they can know the smartphone model, and on the last Android version, they can know the unique install ID. So they can track you everywhere. And the last layers is a behavior layer. They track how you act on a website. Anti-bot systems track the sequence of web pages. So do you initiate your journey with a search query, or do you use a deep link to access data? Are you using CSS, JavaScript, or only fetching HTML? Also, they track the timing of your actions. They track the interval between web pages. They track the delay between mouse clicks. And specifically on the mouse, human tends to move the cursor of the mouse in a natural, fluid manner, often resembling to a Bezier curve. It's completely opposite to straight line movements. And all this information are transmitted to the server at regular intervals. That's why sometimes you navigate smoothly to a website, completing successfully several requests, and suddenly you get a captcha. That's because your score naturally decreases over time. And all these signals are combined together to create a binary classification scores. They blend every signals using machine learning techniques to create and rate your browser fingerprint. And in plus, they use reinforcement learning algorithms to improve and adapt over time. So, when we look at the previous stack, we understand that trying to outsmart the Turing test is a huge challenge. But of course, there is a vulnerability. And this weakness is known as false positive. So let me share with you a very personal example that I experienced 2 weeks ago. So I was trying to purchasing online the train tickets, but when I connected to the website blocked me and said, "You are a bot. Honestly, it took me by surprise. It's my job. Huh? But I just switched to the competitor website. This behavior is known as a false positive. And when you run a business, that's something that you want to avoid at all costs. So anti-bot system must adapt and minimize the false positive. And to do that, there is two approaches. The first one, if they want to use all the available signals, they need millions of clean records for each signal. It's too challenging, too time-consuming, too expensive. So what they are doing, they reduce the number of signals. They focus on the effective ones. And furthermore, there is some signals that are very difficult to get, such as protocol headers. So most of the time, they focus on IP address, HTTP to HTTP headers, JavaScript execution, and behavior trackings. And now, our goal is to understand which signals are used by an anti-bot systems. And to do that, we can use the browser extension Wapalizer. I don't know, perhaps you already use that. This is an amazing extension. It gives you all the technology of a website, especially the security technology inside. And if you want to cross-check the information, you can also open the Chrome DevTool on the network inspectors and check all the requests, and you will find the anti-bot request. There is also some cookie. It's a little bit hidden. I don't want to have any problems. And if you are using mobile applications, you can use interceptor proxy, like the well-known shard proxy or the super HTTP toolkit. I love this product. And also, if you are dealing with anti-bot system, it's important to know that it's better to start with Android application because you can decompile the source code with JDX and perform injection with Frida. It's very interesting because it enables us to understand how some fields are generated, especially the IDs in requests. Also, let's see a little bit of architecture of anti-bot systems. So, when you connect to a website, you also connect to an anti-bot URL. Sometimes this URL is hosted on the website. Sometimes it's hosted on a dedicated servers. And when the browser initiates the connection, it starts to gather all information, as many as possible, like the behavior, the system configuration, etc. The payload may be encrypted or not, depending on the anti-bot systems, and sent to the anti-bot server. In return, the anti-bot server issues a cookie, and this process is repeated over time. And the goal is to monitor the sessions. And now, when you want to access to the website, you connect to the website and you send the cookie along with the request. And the website initiates a server-to-server to the anti-bot servers to get the reputation score. And based on this score, the website either grant or denied us access. That's how it's working. So, as you see, handling anti-bot system can be very difficult. So we need a methodology to do that. Because website and protection quickly evolve. So our approach is incremental. Because maintaining also a scraper can be costly and time-consuming. So let's see one possible methodology. First, you have a scraper. What you can do if the success rate is low, if the requests are not working, you can tune the scrappers. You can modify the delay, you can say, do we use cookie or not? We can change the TLS version. If it's not working, perhaps it's time to use proxy. So let's start with data center proxy. They are fast, cheap, and reliable. Also, you can use Craproxy to efficiently orchestrate your proxy strategy. If it's not working, it's perhaps you don't act like a browser. So let's introduce Puppeteer or Playwright and perhaps some still extensions to bypass the JavaScript fingerprint. And it's not working, perhaps you should switch to a more advanced proxy strategy. So let's use some residential proxy which offer you a lot of location in the world. You can use also ISP proxy, mobile proxy, hardware proxy like ProxyDies. Just to focus on ISP proxy, it's proxy installed on data center, but they have IP address of the internet provider, so like users. And if it's not working, it's perhaps Puppeteer is detected. So you can shift to hateful browsers. There is commercial solution to do that, but you can create your own browser farm. And if everything, all these steps are not working, perhaps it's time to switch to Unblocker API, like the Zite API that we discussed this morning. It will do all the previous steps for you, and you can jump directly to this step also. Perhaps sometime you need to solve some CAPTCHA, so use AI CAPTCHA solvers. They are fast, and they don't use human. And if everything is not working, perhaps it's time to find some antibot token API or try to generate the token yourself. So it's a possible methodology to bypass antibot systems. Also, I would like to share with you some open source tools that are very useful if you try to understand antibots. So thank you very much for your attention, and I will be very happy to answer some questions.
Before we see the questions, I just have an interesting one for you. If you kind of go into the mindset of the antibot systems themselves, are you seeing a correlation in the processing power that's becoming available on the other side to kind of dial up the amount of defenses? Or, do you see that being a factor, or do you see the defenses coming in on a different dimension?
No, in fact, the computing, it's about the machine learning they are using. So they can detect you. We see all the signals. They cannot use rule-based. So now they use machine learning to detect the systems because there is too many combinations. And yes, the power won't help us, but we also have the same technology on our side. So we can try different strategy with machine learning to bypass the system.
Okay, and what about hardware, actual hardware tokens? What's your view on those on the other side that actually detect, the physical device that it's running on rather than a software emulated?
Yeah, there is an article on Google's also to validate the software and the hardware on Chrome. It's a draft for now, but we'll see what they will do with that. I don't know if it's helpful for them, but we will find a way to bypass them.
Fair enough. What about, I've asked the question to others, if you could make one kind of really challenging thing go away in the kind of, in the whole kind of scraping, kind of gathering, extraction space, in your view, what would be the one thing that you'd like to kind of make just disappear?
And to make disappear, yes, there is a new technology on the antibot side. Perhaps you already see that. I assume that you already see that. They use virtual machine on top on JavaScript. So it's another step. There is a lot of antibots. We are just obfuscating the code. Now, most advanced antibots use virtual machine on top of JavaScript. So the goal is to understand how the virtual machine works before understanding the antibot code, because it adds the layers. And I would like clearly to understand how it's works.
Okay, cool. Right, so we have a couple of questions coming in, so let's take them in order. How's the security level generally on mobile apps?
It depends. The beauty of the mobile apps is that they are releasing versions and they cannot update the version every day. So they embark the anti-bot SDK with them, and most of applications have old SDK. And all SDK have poor protection. So that helps us. However, there is now, it's possible they use Flutter to use compile C++ inside the mobile. So it's not helping us.
All right, and listen, this is the last question. Do you see, Scrapoxy actually, going into the managing its own headless browsers?
Let's plan that. Thanks.
All right, listen, thanks so much.
Thank you.
Yeah, brilliant. Thank you.